My name is Tobias Schneider. I'm from Munich, and I'm the guy talking about Flash at a JavaScript conference. What is this talk is about some Flash, some HTML5, and of course JavaScript, because I created Gordon, which is a Flash runtime written in pure JavaScript. Awesome. Yeah, why did I do this project? Because I don't really like Flash. Is it okay? So, yeah, because I don't really like Flash, but I love JavaScript and I love HTML5. Does it? Okay. And for me, there's not just bad parts on Flash, so there's also a bunch of good parts, and these are. I like the file format they use to deliver the content. This is the SWF, or called Swift, and I think this is a really well structured, and it's an extendable file format, so it's really cool. And and I think they did a really great job in creating cool authoring tools to create this Flash content, and to give people that are not well familiar with underlying techniques or with programming stuff or something, the ability to create rich media internet, and they don't have to care about underlying techniques or how it will be run in the browser. So that's really cool. But there's of course a lot of more things I don't really like about Flash, and that's because the runtime really sucks, especially on non-Windows systems. So there's no day that my browser will not crash because of the browser plugin. Yeah, I'm a Mac user, and I think the runtime would also suck on iPhone and on the iPad. And third one is there's a big problem with accessibility and semantics in Flash files. So according to Douglas Crockford, I have to set another statement, and this is: the Flash runtime must die. So give me an R with me. R. So, and like Douglas, I have two of it, but the second is like a fancy one because it has lasers in the background. That's really cool. And what is Gordon? So Gordon is basically it's like a just-in-time converting of Flash files or Swift files into SVG or JavaScript in your browser with no plugin. So it's pure JavaScript. So you can load in your browser a JavaScript file and convert it into SVG and JavaScript. So and there's another one. Why I did this, why I created this project is to skip that Flash intro and open the web. So some facts about Gordon. What is Gordon? Gordon is Flash and France sitting in the DOM. That means you have fully access of the behavior of your embedded Flash files. There's no more black box embedded files sitting in your DOM. You don't have any clue how it's working and what is going on in there. And of course, it's 100% with JavaScript. There's no Flash fallbacks in there, so no web SVG or something to render the output SVG in Flash. It's about 3.1. It's about 3,100 lines of code in total, and it's 15 kilobyte gzip in size. Oh, how can I go back? Yeah, and it's full customizable. So it used SVG by default to doing the rendering stuff, but you could also write in Canvas renderer or in WebGL renderer and use it with Gordon. I will show you an example later. Yeah, Gordon supports the following browsers. It supports Chrome, Firefox, Safari, also the mobile Safari, so it will also run on iPhone and on the iPad. And it supports the latest Opera. Yeah, what about the Flash compatibility? Gordon supports the full Flash 1 features. It supports all Flash 2 features except of embedded sound. And I'm currently working on Flash 3 features. So they're over 70% done. So how do you use Gordon? So it's really easy. So after you downloaded the main file and included it in your website, you just have to create an instance of Gordon Movie and pass the path to your SVF file, and giving some options like the width and the height and the autoplay, which calls Gordon to play the file immediately or have to wait to another statement. So then you can use the movie file in this chaining method way that you maybe know because of jQuery. Yeah, and how did Gordon do this? They first have to load an SVF file, and the Swift file it's a binary file. So how do you load load and parse a binary file in JavaScript? So that's really easy. You have just create a regular XML HTTP request object, but you have to write the MIME type with the override MIME type method. So to avoid that the browser interprets it as a UTF-8 file, and by setting this method, by overriding the MIME type, you tell the browser to parse the binary data as an ASCII file. In Gordon, I have to deal a lot with different file formats. So it is not just the problem to parse an SVF in Swift file format. So there are also a lot of other embedded file formats like sound, like video, or images. So I do that with this data URL, which lets you encode a binary data stream and attach it to an image tag, so you can embed all your files inline in your markup. So what techniques are Gordon use to render a Flash file in a browser? So it uses these HTML5 techniques. So you use web workers to load the SVF files in the background and to parse the frame information of an SVF. So you can parse the SVF file in the background without to block the user interface. And it uses SVG to do all this rendering stuff. And of course, Canvas. So how can Gordon, so we see how Gordon can load a binary data. And the SVF file could also be compressed. So Flash uses a Zlib decompressing algorithm to compress a Flash file. So how could you use that in JavaScript? So the one way is to use this inflate.js library by Masanao Izumo. It's a port of the Zlib compression algorithms in JavaScript. And it works very well, but it takes too long time. So it took for a 32 kilobyte compressed data about 150 milliseconds. That's tested in the V8. And that is definitely too long. And yeah, the other matter, when Gordon implements it's an own Zlib implementation, and it took just 50 milliseconds. That's about 10 times faster than the other one. And how Gordon did that is could be really interesting because it's some kind of art. Because imagine you have a Zlib compressed data string, and you want to decompress it in the browser. So what I did is I remembered that the PNG file format also compressed his image data. And what I do is I take the compressed data string, wrap a PNG header around it, encode it with base64, attach it to an image tag, draw that image tag into a canvas, and then read the color information of each pixel out of this canvas. That's how I get a performance improvement for about 10 times. That's really cool. Yeah, what is already implemented in JavaScript of the SVF file specification? It supports all kinds of shapes. Yeah, so a shape is defined in a Swift file. There's just a bunch of path points and information about the fill style and the line style. I will give you some cool demos after that presentation. So I know my English really sucks, but excuse me. They use all kinds of images, so there are different types of images inside of a Swift file. They could be embedded JPEG files, embedded PNG files, embedded GIF files. So that's really to read them out, to encode in base64 and attach them to an image tag. That's really easy. But it could, yeah, but in the most JPEG pictures inside of this SVF file, the JPEG tables and the header information are separated from the data. So if you have more than one images in your SVF file, that saves a lot of memory to do that kind. They could, okay. They also support all kinds of embedded fonts and text inside of a Swift file. So it just converts the fonts, glyph, path informations into path informations of SVG. So but currently, it's just the WebKit supports embedded SVG files, and Opera should support it, but for some reason it doesn't work for me. There's another way to get embedded fonts to work in Firefox, or two ways, is to just set the path information of each shape inline, or you can create an ODT file or an embedded web form file, and encode it with base64 and attach it to a data URL. So it supports buttons for interactivity. I've not implemented yet morphing. So this is, in a Swift file, they just defined the start shape and the end shape, and do all this transition and transformation stuff between these two shapes I have to done by the runtime. I've not implemented it yet, but there's a really, really great solution in Raphael.js. So I think Dimitri will show something. There are sprites. Sprites are just Swift files inside of another Swift file. So they have their own timeline, they have their own set of frames. And I will show you in the demo later. Sound is not implemented yet, because there are two types of sound in a Swift file. It's embedded sound, which means that the raw data of a sound file is embedded into the Swift file. And there's another method, and there's another type of to just define and sound tag, like it's similar to the HTML5 sound tag, that gives you access over an API, so that makes the sound scriptable. So it's not embedded in a Swift file, so you can instead load an external sound file into this. Also video. Embedded video is not implemented yet in Gordon. But there's another solution, is the video frame, just to define a video frame which is scriptable via JavaScript or ActionScript. Gordon supports scripting, like ActionScript. So there are two action models defined in the Swift specification. The first action model was just a bunch of simple instructions like play, stop, next frame, previous frame, go to frame, wait for frame, etc., etc. And they introduced ActionScript 1 in the Swift 4 implementation. The ActionScript is just compiled into the Swift file. It's compiled into bytecode. So there's a bunch of instruction which is interpreted by a stack-based virtual machine. So if you have a statement like this, 1 plus x multiplied by 3, then it will be compiled into this bytecode or in this bytecode instructions. So it's push a string on top of a stack, then get the value of the variable with the name is on the stack as a string. Then push another value on the stack, then call the action multiply, which pushes the two values from top of the stack, multiplied it, and pops the two values from the stack and multiply it and push the result back to the stack. And then there's the Swift 9 action model, which is actually ActionScript 3. Anyway, here's an example how you can write your own Gordon renderer, like a WebGL renderer if you want, or a Canvas renderer. You just have to define a custom class, which have three methods. It's define, it's place, and remove. And you can take the SVG renderer of Gordon as an example. So I think it's better I show you some demos, because I really fucked up. So let's start with a simple animation demo. So this is the Flash IDE, and we just open one of the demo files which are shipped with the Flash IDE. Must be here. Flash. It must be. Yeah, there it is. So it's a simple animation. It can show you running in Flash. So you can see it's not very spectacular. So I'll show you how to run this in Gordon. So just export it as a Swift file, like this. So just save it as test.swift. Yeah, we can check. That's okay. Get in my head. Let's create some demo file. Create a new instance of Gordon movie. Pass the name of the Swift file to it. And let it run in the browser. So here it is. Here it is. Here we go. Yeah, and this is a Flash file interpreted by JavaScript, converted into SVG. So I will show you that I'm not lying. So here it is. That's the output. And it works really, really smooth. So let's create another example. Yeah, I want to show some scripting stuff. So let's create a movie. So a Swift file that plays a movie over a net stream. So we can just go in there, create a new file, new Flash document. So we just have to create a video frame, and we choose video, which can be scripted by ActionScript. So drag it into the stage. Make it to full screen. Yes. 150. Yep. Adding some JavaScript, ActionScript, sorry. ECMAScript, sorry. Yeah, it's better. We just need a new net connection object. And create a new net stream object. Oh, we have to give this video frame an instance name, so we can exit. So we can access it via script. Call it my video. I should eaten something before start drinking. So, okay. then attach the NAT stream to this video instance. Attach video. Let's play Big Buck Bunny. Start playing it. Yeah, we're finished. We have to save it as a Swift file. There it is. You can overwrite this. That's okay. And I hope it will work. So. Oh, just have to change this here from test to video. And run it. I'm sorry. What's the problem with there? Okay, just pretty code and I just copy and paste it. So yeah, this should work. Yeah, here it is. Here's our video. Yeah, we have NetStream, full scripting NetStream support in Gordon. And you can see the script Gordon is decompiling from the bytecode inside of this Swift file and runs it as JavaScript. You can see here the output. Here it is. And it works. So I have another demo. This is really, I think it's really cool. No, we'll try it here. Here it is. It crashed, sorry. Yeah, this is the slideshow view running in Gordon. And it's really, really fast. And each slide is loaded as a Swift file. And it's interpreted by Gordon. So you can use any presentation on SlideShare to let it run in Gordon.
Thank you.
So yeah, that's it.